We are done with the last topic on the standard formulas of getting the indefinite integral. So that is the integration by parts. Now we move on to the algebraic substitution, and after this algebraic substitution, we move on to the trigonometric substitution. But for this algebraic substitution, for the solution for this one, we'll let a variable that if we assess or we inspect will make the equation complicated. Then after we substitute a variable, we get the derivative, then we substitute it to the original equation. So say for example, number 1, we have here evaluate the integral of 4x minus 1 dx over 2x plus 1 raised to 3. So for this one, if we are going to rewrite, because if we are going to get the derivative for this one, there's no such because of the numerator, which is 4x minus 1, and for the denominator, which is 2x plus 1. So what are we going to do with this one? We are to rewrite this in such a way that we have to show the denominator, which is 2x plus 1. So if I'm going to rewrite this one, that is also equal to the integral of, okay, so we first remove the square root sign there, so that is 4x minus 1 dx all over, so that is 2x plus 1 raised to 3, and that is of course raised to 1/2 since that is in square root. So if we're going to rewrite this again, that is just 4x minus 1 dx all over. So if we are going to simplify this, that is just we multiply the powers or the exponents, which is 3 multiplied by 1/2, which is 3/2. Okay, so that is 2x plus 1 raised to 3/2. And if you're going to rewrite this again, since the numerator doesn't satisfy the denominator, which is 2x plus 1, we rewrite the numerator as 2 multiplied by 2x plus 1 minus 3. Since if we are going to simplify this further, if we distribute 2 there to the term, that is 4x plus 2 minus 3, and that is also equal to 4x minus 1. So that is the same with the numerator. So that is in terms of 2x plus 1, and the denominator is 2x plus 1. So that is all over 2x plus 1 raised to 3/2, and that is the integral. Okay, so we are now ready to get the integral for that one using the algebraic substitution. But first, we have to separate the two terms of the numerator, which is also equal to the integral of 2 multiplied by 2x plus 1, and then that is dx all over the denominator, which is 2x plus 1 raised to 3/2, and then that is minus the integral of 3 dx all over 2x plus 1 raised to 3/2. So we have just separated the two. So now we let a variable that is we think that it is complicated in our equation. So we have there, we let a variable u that is equal to 2x plus 1. So that is, we get the derivative for this one, that is du is equal to 2 dx, and that is of course plus 1, that is plus 0 already since the derivative of a constant is 0. So now we rewrite this one in terms of dx. So that is dx is equal to du all over 2. Okay, so that is substituting all the values. Substituting the values to our um, equation, this one, okay, substituting it here, so we have there already, okay, that is we bring out the constant 2 there, that is equal to the integral of 2x plus 1, that is already equal to u, so that is u, and then for the dx, that is du all over 2, so that is du all over 2, and then for the denominator 2x plus 1, that is of course u, and then raised to 3/2. And then minus, we bring out again there 3, since that is a constant, that is 3. The integral of dx again, that is du all over 2x plus 1, that is u, and then raised to 3 halves again. Okay, so if we are going to simplify this further, let us bring out 1 half there, that is considered as du over 2, that is considered as 1 half. And then if we bring out 1 half there, okay, that is just 2 multiplied by 1 half, and then we copy there the u du all over u raised to 3 halves. Okay, so copying that one, it will give us u du all over u raised to 3 halves. And same with the second term, let us bring out there 1 half, so it will become 3 multiplied by 1 half also, and that is the integral of du all over u raised to 3 halves. Okay, so that is a power. Okay, so simplifying that further, okay, let us bring up u raised to 3 halves. Okay, so that is we get the reciprocal for that one, so that we may be able to simplify further. Okay, so that is, we cancel this one, that will become 1. Okay, that is equal to the integral of, we bring up there u raised to 3 halves. So that is, we multiply it, if we're going to rewrite, that is u du, and then minus, that is 3 halves, and then that is, we get the reciprocal of the denominator, which is u, and it will become negative already, negative 3 halves, and then that is the u. Okay, now we are ready to simplify this further, since if we are going to multiply u raised to 3 halves and u, that is of course considered as raised to 1, and then 3 halves plus 1, we just add. Okay, okay, so that will become uh sorry, this should be negative 3 halves. Okay, so negative 3 halves, okay, negative 3 halves plus 1, that is equal to negative 1 half. So if we are going to rewrite again that one, that is the integral of u raised to negative 1 half du, and what remained there is 3 halves square, the integral of u raised to negative 3 halves du. And okay, we are now ready to integrate that one using again power rule. So that is the integral of, okay, that is u raised to negative 1 half plus 1, since that is the rule of power, and then we get the exponent, which is negative 1 half plus 1 again, and then that is minus 3 halves. Okay, that is u raised to negative 3 halves plus 1 all over negative 3 halves plus 1. So that is already plus c. And if we're going to simplify that further, since negative 1 half plus 1 is just raised to u raised to 1 half, and then same with the denominator, which is 1 half, and then that is minus 3 halves multiplied by u raised to negative 1 half already, and then all over negative 1 half. Okay, that is plus c. Okay, so if that is our answer, we just get the reciprocal for this one and this one to simplify that further. So the reciprocal for this one, 1 half, uh, we bring up 2 there, so it will become 2 u raised to 1 half. Okay, that is already plus, since that is negative divided by negative, that is plus, and then we bring up 1 half there, so it will become 2, so 2 will be cancelled, what remained there is 3. Okay, that is u raised to negative 1 half also, plus c. But don't forget that for our original equation, that is in terms of, okay, that is in terms of x. So this one, that is in terms of x, so our answer should be in terms of x. Okay, so our value for u there, that is 2x plus 1, so we substitute there. Okay, the value of u is equal to 2x plus 1, so substituting the value of u, that is also equal to 2 multiplied by 2x plus 1 raised to 1 half plus 3 multiplied by 2x plus 1 raised to negative 1 half plus c. So that will be our final answer for the integral using algebraic substitution. Okay, we have here again example number 2, evaluate the integral of sine square root of y dy, and what is complicated there is of course the square root of y. So we let a variable x again to be equal to the square root of y, and since if we are going to get the value of y there, we square both sides so that the square root will be cancelled, so that will become x squared is equal to y, and getting the derivative for that one, that is 2x dx is equal to dy. Okay, we substitute now the values to the original equation, which is the integral of sine square root of y dy. Okay, so getting that one, that is the integral of, okay, sine, and then that is square root of y, that is already x, and then what is the value of dy, that is 2x dx. Okay, and then after that we uh, just rewrite this one. Since that is a constant, we bring out the constant, which is 2, and what remained there, we just interchange this one, we just rewrite that one, that is x, okay, sine x d x. Okay, so if we are going to get the integral for that one, if you remember again the integration by parts, so we may solve this one using integration by parts. Okay, okay, so using integration by parts, first we let u be equal to x, this one, that is our u, and this sine x dx again, that will be our dv. Okay, so letting u be the x, and then we get the derivative for this, that is du is equal to dx, and we get again the value of dv there, that is equal to sine x dx. Okay, to be able to get the value of v there, we integrate both sides. So integrating that both sides, we get the value of v, and the integral for sine x, that is negative cosine x. Okay, for the formula of integration by parts, that is, if you remember, that is the integral of u dv is equal to uv minus the integral of v du. So we substitute the values to this equation. Okay, so what is the value of u there? That is equal to, okay, but we don't forget the 2 there, the value of the constant, which is 2, and then that is multiplied by, okay, so for u that is x already, and then for v that is negative cosine of x. Okay, and then we get the integral, that is minus the integral of, for this one, that is the integral of v, that is again negative cosine of x, and then du there is dx. Okay, this one. Okay, so simplifying this further, um, we just simplify the negative multiplied by a negative sign, so that will become 2 multiplied by x, that is already negative, yes, that is negative cosine of x, and then that will be plus, and then the integral of cosine of x dx. So getting the integral for this term, that is equal to, so we rewrite again, that is 2 multiplied by negative x cosine of x, and then that is plus sine x already, since the integral for cosine, that is positive sine of x, and then plus c. Okay, so if we are going to distribute again the value of 2 there, the constant, that is negative 2x cosine of x plus 2 sine x plus c, and don't forget that the value of x, okay, sorry, okay, the value of x is equal to the square root of y, since our original equation is in terms of dy, so that is supposed to be in terms of y, not in x. So substituting the value of x there, that is equal to negative 2 the square root of y, and then cosine the square root of y plus 2 sine the square root of y plus c. So this will be our final answer integrating example number 2. Okay, so example number 3, we have there the integral of v cube a squared minus v squared raised to 1 half dv. So if we are going to assess the equation, what is complicated there is the second, that is a squared minus v squared raised to 1 half. So if we are going to rewrite this one, let us remove the square root there, that is 1 half, so that is raised to 1 half, so that will we get that one, multiplying that and then raising it to 2, so that will become x squared is equal to a squared minus v squared, and getting the derivative for this one, that is a algebraic substitution, so that is 2x dx is equal to negative 2v dv. Since a squared there is a constant, so the the derivative of a constant is 0. So we rewrite this one in terms of dv, since our original equation is in terms of dv. So that is equal to, we divide both sides by negative 2, that will become negative x dx all over v. Okay, so that is again dv, since that is in terms of dx, we have to express v in terms of x again. Okay, so uh, it conforms, it should be in terms of x also. Okay, so x squared is equal to a squared minus v squared, and v squared there is equal to a squared minus x squared, and getting v, that is equal also to the square root of a squared minus x squared, or if we can rewrite that one, that is also equal to a squared minus x squared raised to 1 half. So substituting again the values there, since we have here, okay, so rewriting that one, that is dv is equal to negative x dx, and for the value of v, we get this one, so that will become a squared minus x squared raised to 1 half. So substituting the values, substituting all values to equation, to our original equation, so it will give us equal to, so copying that one, so for our original equation, that is v cubed, so v there is already a squared minus x squared raised to 1 half, and that is raised to 3, and then we multiply the value of a squared minus v squared raised to 1 half as x, since we substitute a variable there, which is x already, and then x, and then we multiply it by dv, so this one, so we get the value of dv here. Okay, so that will become negative x dx all over a squared minus x squared raised to 1 half. But we can cancel this out, since that is in the numerator and this is in denominator, and all of this one is a product, so we can cancel this one, we cancel this out. So what remained here, okay, what remained here is of course 2 already. Okay, so if we have that one, we can simplify that further, that is the integral, okay, of a squared minus x squared, and then we distribute already x to the x dx, okay, that will become negative x squared dx. Okay, so getting the value for that one, okay, so simplifying it, we distribute the negative x squared to the terms, so that will become equal to, we bring out negative there, so that is being negative, the integral of a squared x squared plus already, and then that is negative x squared multiplied by negative x squared, that will become positive x raised to 4, and then that is dx again. Okay, so if we are going to separate these two terms, it will become negative the integral of, so don't forget the negative there. So that is a squared x squared dx, and then minus the integral of x raised to 4 dx. Okay, so if we are going to get the integral for that one, so we are now ready. Since a squared there is a constant, we bring out that one. So this one will become negative a squared, and what remains there is a power rule. So this will be power rule already. Okay, that is x cubed all over 3, and then minus x raised to 5 all over 5 plus c. But we are not yet done, since our original equation is in terms of v again. So that is v, that is not x. So we get the value of x, which is a squared minus v squared raised to 1 half. So we get that one. Okay, so that is x is equal to a squared minus v squared raised to 1 half. So substituting the value of x to the equation, that is also equal to negative a squared multiplied by a squared minus v squared raised to. So that is raised to 3 multiplied by, that is just multiplied by 1 half, and it will become 3 halves. Okay, so that is raised to 3 halves all over 3. And that is also equal to x raised to, since that is 1 half multiplied by 5, that is 5 halves. Sorry, that is in terms of already v. Okay, that is multiplied by a squared minus v squared raised to 5 halves all over 5 plus c. So that will be our final answer. That is the integral of example number 3. Okay, moving on to example number 4. We have here, evaluate the integral of the square root of x minus a multiplied by x plus a all over x. So if we are going to rewrite this one, since that is a perfect square binomial, that is the integral of x squared minus a squared already. Okay, so if we are going to let again, since what is complicated there, that is the integral, that is the square root of x squared minus a squared. So we let again a variable u to be equal to the the square root of x squared minus a squared. So we may get the value of u there. That is also equal to u squared is equal to, we square both sides, the square root will be cancelled, and that is x squared minus a squared again. Okay, getting the derivative for this one, that is also equal to 2u du is equal to 2x dx, since a squared is already 0, since that is a constant and the derivative of a constant is 0. Okay, so we rewrite this again in terms of dx, since our original equation is in terms of dx. Okay, so rewriting this one, we divide both sides by 2. Okay, that will become, okay, that is dx is equal to u du all over x. Okay, so that is in we have rewritten this one as in terms of dx. So since our numerator there is in terms of u, the denominator here is supposed to be in terms of u also. So we get the value of x there in terms of u. So that is, if we are going to rewrite this equation, that is x squared is equal to u squared plus a squared, and x there is equal to the square root of u squared plus a squared. Okay, now we substitute the value of x to our equation. So that is dx is equal to u du all over x, which is the square root of a squared plus a squared. Now we are ready to substitute all the values to our original equation, which is this one. Okay, so substituting the values to our equation, it will give us equal to Okay, that is the integral of, since the value of square root of x squared minus a squared is already u, we get the value of u there, that is u multiplied by. Okay, so for the value of dx, this will be the value of dx, so that is u du all over the square root of a u squared plus a squared already, and that is all over, so that is with the integral sign. So that is x. The value of x there is already square root of u squared plus a squared. Okay, so simplifying that further, it will give us, since we, that is in the denominator, that is a fraction, we get the reciprocal for this one, so we multiply the denominator for this one to the numerator here, so that will become the integral of, if we are going to distribute u there, that will become u squared already, so that is u squared du all over, so that will become u squared plus a squared multiplied by u squared plus a squared. So if we're going to multiply that one, the radical sign will be cancelled already, and what remains there is u squared plus a squared only. So that is u squared du all over, that is u squared plus a squared. So for this one, we cannot simplify this using any methods or any standard formulas using integral. So what we have to do here is divide. Okay, so dividing, if you are going to divide this one, u squared divided by the divisor, which is u squared plus a squared, and the quotient for this one is of course 1, and then 1 multiplied by u squared, that is u squared, 1 multiplied by a squared, that is plus a squared, and we subtract this one will become negative, this one will become negative, and this one will be cancelled, so that is a raised to 2. So this will be the remainder. So if we are going to rewrite this one, that is equal to the integral of course, we get the quotient, that is 1, and then the remainder, which is a squared, and then divided by the divisor. Okay, that is in du. So now we get that one, we simplify that further. If we are going to separate these two terms, that is the integral of du, okay, minus the integral of a squared du all over u squared plus a squared. So since a squared there is a constant, we can now um, bring out a squared, and what remains there is du all over u squared plus a squared. So if you remember again the trigonometric formula, the trigonometric function, so we can use trigonometric function for this one, that is just 1 all over a, and then that is the arctangent of u all over a plus c again. So that is, if we are going to simplify that, that is du, so that is u already minus, okay, we bring out a squared there, and that is multiplied by 1 all over a using trigonometric function, that is already arctangent of u all over a plus c. Okay, so that is, we can rewrite this one, we can cancel this out, we can cancel this one, and what remains there is already u minus a, the arctangent of u all over a plus c. But we are not yet done, since the value of u there is equal to, okay, since our original equation is in terms of x, so we have to write our answer, our final answer, in terms of x also. So the value of u there is, don't forget, that is the square root of x squared minus a squared. So that is the square root of x squared minus a squared. Okay, so substituting u there, that is also equal to the square root of x squared minus a squared minus a arctangent of u, which is u, that is the square root of x squared minus a squared all over a. So that is plus c. So that will be our final answer. Okay, so for the second to the last example, we have here example number 5. Evaluate the integral of dx all over x cubed minus x a squared. So we have here a common factor for the denominator, which is x. So we factor out x there. That is, if we rewrite, that is the integral of dx all over x, factor out x, and then multiplied by x squared minus a squared. So now we let again for the value of 1 all over x, and then we let x be equal to 1 all over u, since that is the complicated term there or variable there in the equation. So if we are going to rewrite again x, that is equal also to the reciprocal of 1 all over u, that is u raised to negative 1, and getting the derivative for x, that is dx is equal to negative u raised to negative 2 du, and we have to write this one in terms of dx. So since our formula, our equation, sorry, that is in terms of x, so we have to write this one in terms of dx. So that is equal to negative du all over u squared. Okay, so substituting the values to our equation, so this one, that is equal to the integral of dx, there is already negative du all over u squared all over. So that is 1 all over u multiplied by, since x squared, there is already 1 all over u squared. Since 1 times 1, that is 1 divided by u times u, that is u squared already. So that is minus a squared. Okay, so simplifying this further, let us bring up this one, since that is a fraction. So we get the reciprocal for 1 over u, and the reciprocal of 1 over u is u. So that is the integral of, let us bring out negative there, so it will become u du all over. So what remained there is the divisor, which is u squared, and then we just copy the reciprocal for this one, that is 1 all over u squared minus a squared. Okay, so if we are going to simplify this, that is cancelled, and what remained there is u. Okay, so if we are going again to simplify this one, that is negative the integral of du all over, so we get the least common multiple for this one. Okay, so that is uh sorry, we first distribute u there, so we distribute u there, and then for the second term for that, so that is 1 all over u already. So u divided by u squared, what remained there is 1 all over u. So the 1 all over u minus u squared a squared. Okay, so that will be uh, the value for that one, and getting the least common multiple for the denominator, which is du all over, the least common is u, and then that is 1 minus already, and then that is u divided by 1, that is u, and then multiplied by u squared a squared. It will become already, okay, that is, okay, this one should be, sorry, this one should be, I just erase this one. Okay, that is what remained there is u, not u already, not u squared, so that is u a squared, and then that is minus, of course, u multiplied by this term, so that is u squared a squared, and we get the reciprocal again for this one, that is also equal to the integral of u du all over 1 minus u squared a squared. Okay, so if we are going to get the derivative of the denominator, which is 1 minus u squared a squared, that is also equal to 0 minus that is 2 u. What remain there is a squared since that is a constant, and then that is the u. And if we have here this one, it doesn't satisfy again our numerator u du, so we have to multiply and divide it by negative 1 half. But we have here again negative, so don't forget negative there. That is negative already, and that is if you're going to manipulate, that is 1 half. Yes, that is 1 half a squared, the integral of, that is 2 u a squared du all over, that is minus, okay, that is all over 1 minus u squared a squared. And since the derivative already of the denominator is the numerator, we get the rule for the logarithm. So that is equal to negative 1 all over 2a squared, the logarithm of the denominator, which is 1 minus u squared a squared plus c. But don't forget again that u is equal to 1 all over x, since our equation is in terms of x. So substituting the value of u to our answer, that is equal to negative 1 all over 2a squared, and then the of natural ln of 1 minus, okay, that is 1 all over x, then raised to 2a squared plus c. Or if you're going to rewrite that one, that is 1 all over 2a squared, the logarithm of 1 minus, that is 1 all over x squared, or that is a squared all over x squared plus c. So that will be our final answer. Okay, moving on to our last example, example number 6. Evaluate the integral of x dx all over x squared minus a squared raised to 3. So for this term, of course, the complicated term is x squared minus a squared. So we let that one as equal to u. And getting the derivative again, that is 2x dx, then is equal to du, since negative a squared there is a constant and the derivative of a constant is 0. So that is if we are going to rewrite again our equation, since the numerator is in terms already of x dx, so we rewrite that one, x dx is equal to du all over 2. Okay, so substituting the values to our original equation, that is equal to the integral of x dx, there is already du all over 2 all over, that is x squared minus a squared is already u, so that is u raised to 3. Okay, so that is equal to, we bring out there 1 half, so that will become 1 half the integral of, we get the reciprocal of u cubed, that is u raised to negative 3 already, and then that is the u. Okay, so getting that one, simplifying that, getting the derivative, of course, that is 1 half, and then that is already u raised to negative 2, since negative 3 plus 1 is negative 2, divided by the exponent, which is negative 2, so that is plus c. Okay, so simplifying that further, it will give us 1, okay, negative, that is u raised to negative 2, and that is all over 4 plus c. But don't forget again that our value of u is equal to x squared minus a squared, since our original equation is in terms of x. Okay, so that is equal to, also that is negative x squared minus a squared raised to negative 2 all over 4 plus c. So that will be our final answer. So that ends our discussion on algebraic substitution.